I would now like to review problem 14-20 with you, and it's net present value analysis with uncertain cash flows. I'm not sure we should lay out $250,000 for the automated welding machine, said Jim Alter, president of the Superior Equipment Company. That's a lot of money, and it would cost $80,000 for software installation, another $36,000 per year to maintain the investment in the welding machine. In addition, the manufacturer admits it would cost $45,000 more at the end of 3 years to replace worn out parts. So let's look and separate the investment from the cash, the investments as well as either cash inflows over the course of all 6 years, or also note if there's a cash inflow or outflow in one particular year. And in this paragraph, the first paragraph, we have the investment of $250,000 given to us, and we also have the installation fee of $80,000. So right now, our investment includes the cost of the machine and the software installation. Now, they gave us a $36,000 per year just to maintain the actual welding machine, and it's each year. So we want to look and include our yearly cost or inflows in one bucket, and then also note other cash inflows or outflows that only happen in a particular year. So the $36,000 per year would be an increase in maintenance costs, so it would be a cash outflow and would be used to reduce any cash inflows. But the replacement of worn out parts isn't a yearly, so we would treat that and recognize the adjustment for the $45,000 replacement of worn out parts would just be in year 3. I admit it's a lot of money, says Francie Rogers, the controller, but you know the turnover problem we have with the welding crew. This machine would replace 6 welders at cost savings of $180,000 each year. So that would be part of the bucket where we're summarizing our costs that occur each year for the 6 years, which would be a cash inflow of $108,000, and we would save another $6,500 per year in reduced material waste. When you figure that out, you will see that the reduction in waste, we have a total cash inflow of $114,500 less what was given to us in the first paragraph of the $36,000 increase in maintenance costs per year. So our annual cash inflows for the next 6 years will be $78,500. I'm still not convinced, countered Mr. Alter. We can only get $12 scrap value out of our welding machine if we sell it now, and in 6 years the new machine would only be worth $20,000. But have your people work up the figures, and we'll talk about it in the next executive committee meeting. So we find out that we can salvage our old equipment for $12,000, which is subtracted from the investment of $250,000 and the $80,000 software installation, which gives us, and the salvage value will decrease the investment by $12,000. So our overall cash flows are investment now for the welding machine is $318,000. And our annual net cost savings is $78,500. So now let's look at each year. In year 1, Our annual cost savings is $78,500, and we would take that $78,500 and go to the present value of the single sum, which is the first exhibit in Appendix 14B, at 16%. So in the one column, it would be 0.862, and multiply that by the $78,500, which is $67,667. In year 2, we again have the $78,500 annual net savings. And in year 2, at 16%, the factor in the first exhibit in 14B is 0.743. You multiply that 78,000 by the factor in period 2, and that's 58,326. But now in year 3, we have to recognize that we have a $45,000 cash outflow because of the actual replacement parts. So our cash inflow is $33,500. So in period 3 at 16%, the factor is 0.641, which is $21,474. In year 4 and 5, the cash inflows is $78,500 for each year, and in year 4 the factor is 0.552, and in year 5 the factor is 0.476. So year 4, the present value of the cash flows is $43,332, and in year 5 it's $37,366. But year 6, we have two cash inflows. We have the $78,500 as well as the $20,000 that is the result of selling the new machine, or the selling of the new machine. They estimate would be $20,000 at the end of the 6th year. So our actual cash flows in year 6 is the $98,500. The factor for year 6, period 6, is at 16%. For the present value of a single sum is 0.41. So the present value is $40,385. Now, if you add the present value of the cash inflows, they would add up to $268,550. And if you compare that to the $318,000, our net present value is a negative $49,450. The last requirement: assume that management can identify several intangible benefits associated with the automated welding machine, including greater flexibility in shifting from one type of product to another, improved quality of output, and faster delivery as a result of reduced throughput time. What minimum dollar value per year would management have to attach to these intangible benefits in order to make the new welding machine an acceptable investment? Well, as we noted in our net present value calculation, there was a negative $49,452. And what the question is asking, how much should the benefits, the intangible benefits, be each year for the next 6 years that it would make this investment desirable? And you would take the $49,450, and because it's each year, it's an annuity, so you would use the second table in 4B-2, the present value of an annuity because it's the same amount each year. And that would give you $13,419 per year to make this a desirable investment for the welding machine.